Welcome to Rges Algebra 2. This is Lesson 26A, and we'll be discussing 8.1 through 8.3. Your assignment on Monday will be 8.3, and it has to do with scientific notation, so we'll review that very quickly, and then I'll also review some 8.1, 8.2, which is regarding using exponents and simplifying. So we'll do a few more of those because 8.1 and 8.2 will form the foundation of your quiz on Wednesday. So let's go ahead and start with scientific notation, partly because I consider this a topic that for most of you would just be review, and I've already gone over it once. But let's say I had first off, I'll think of a very large number, very small number, 0.000321, and a very large number. Keep putting a decimal there. Okay, let's see. 287,000,000. So if I were to write these two in scientific notation, I want to look at the number part with one decimal point. The number part with one decimal point. Then in the first example, I will have 10 to a power, and it will be a negative power because it's representing a very small number. And I moved this decimal point to there, right after the 3. So how many places is that? I'm going to count the 3 and 3 zeros. That's -4. In the next one, I moved the decimal point to right after the 2. So I've got 2 more numbers and 6 more zeros. So that is 10 to the 8th. Now if we're going in the other direction, I'll simply take something to a scientific notation. Let's say I want 3.9 times 10 to the 5th, and then I want 2.07 times 10 to the -7th, let's say. How would I convert these to numbers? Well, this will represent a larger number. I'm going to write my number parts, 3 and 9. I've moved my decimal over one place, and then I need 4 more places. So I'll need 4 zeros. And so that will be 390,000. Okay. Here, I'll write my numbers, 207. I'm moving to the left because I want to make a real small number. Probably should have given myself some room, actually. Okay. I've moved my decimal to the left once because I'm getting ready to make a small number because it's to the negative power. And now I need 6 more zeros. 1, 2, 3, 4, 5, 6. Point. So now altogether, I've moved it 7 places. Okay, see how that works? And so this is a very small number represented by that. This is a large number represented by that. That's really all there is to scientific notation. If you need a bigger explanation, I'm treating this kind of casually because I think that most of you have worked with scientific notation before. But if you need a better explanation, don't hesitate to ask. I'll be happy to go over it in a slower way. Now let's go ahead and pick up about 4 example problems for review from 8.1 and 8.2. Now recall when I have something like a to the 3/2, the denominator represents the root and the numerator represents the exponent. So if my directions are, I want you to express this rather than in a fractional power, I'll go ahead and express it with with radical signs and powers with positive exponents. So this will equal, I want the radical sign, so this will be the square root, because the denominator represents the root, and a cubed under. Or I could say the square root of a and the entire thing cubed. And I'm not seeing anything in those directions that would indicate one or the other. Okay, so let's look at another problem. So it says, for the directions here, simplify taking only principal roots. Okay, so I won't take a negative root. This tells me that I'm going to take a cubed root, and the cubed root of 64 is 4, because 4 times 4 is 16 times 4 again is 64. And this tells me that I'm going to take that 4, and I'm going to square it. So 4 squared is 16. Because a negative squared will be positive, so this will be a positive 16, and this tells me it'll be in the denominator. So that's the way that works. You don't have to write intermediate steps if you can follow that. Now again, how did I do it? This was my first step. I took the cubed root, then I squared it, which dealt with both the changing 4 to 16, but also dealt with my negative sign here. And then I dealt with the negative exponent, which dropped it to the denominator. Okay, I'm going to give you a couple more. The real trick with these is just to remember your rules, right? Express without a denominator. So if I'm dividing, I'm going to subtract. So this becomes... Actually, I could do it, subtraction, right, 4 minus a negative 4. Or I could think to push this up to the numerator, so that'd be n to the 4th times n to the 4th. Either way you want to think about this, okay? So this becomes n to the 8th. Let's look at another one. The directions for this says simplify the following, expressing the results with positive exponents. Okay, so now I am going to go ahead and take this cubed root of a square root, essentially here. So that'll be to the 6th, right? 1/6 when I'm multiplying, this will be multiplying 1/3 times 1/2, okay? 1/6 in the denominator. This, and I'm multiplying here with the b, okay? I'm taking 1/3 times 1/3 because of the radical sign, times 3, so that's 1. This says 6, right? That's 1, and this negative means that that goes b to the 1, or just b goes in the denominator also. So you'll just put a 1 as a kind of a placeholder in the numerator. Let me try a couple more. Here it asks you to have no denominator, and but go ahead and have negative exponents if you need it. So we'll just simply move that up, a to the m. Typically you write your variables in a chronological or alphabetical order, I should say. And so my n now becomes negative n and c to the x. And I'm trying to do a bunch of mixed up problems here. Maybe I'll just do one more for you. And just trying to give you lots of practice with this. Okay, this one wants to, that's a division sign, sorry. This one wants to be expressed with a radical sign. They both are with a 3 in the denominator, so that'll mean a cubed root. The a will be squared, and the b will be to the 1st power. Whoops. That's not right. Let's see, how did I do that? There we go. I ignored that sign there. So let's do that different. There we go. So I need to divide that a squared under the cube. This will also be under, let's get my writing back.